Hello friends, welcome to Learners Forum. So this video is about the nodal analysis continuation. So in last video we saw about the nodal analysis and the procedure to solve the problems based on nodal analysis. Now let us consider the nodal analysis with voltage sources where we have two cases. Under the first case, when voltage source is connected directly between the non-reference node and reference node, then the node voltage at the non-reference node will be equal to the specified voltage of source. So we have saw the example for these particular cases and we have identified how the nodal voltage is equal to the specified voltage also. The second case is when voltage source connects two separate non-reference nodes, then the nodes need to be combined into a single node. So this particular node is called the super node. Suppose if we have two nodes like this V1 and V2 and we have a voltage source in between, then this particular junction is called as a super node. That is, we have a voltage source which is connected in between two non-reference nodes. So whenever we have circuit of this particular kind, then we have to follow this particular super node analysis. Now let us see the definition of super node analysis, the properties, and then we can solve the problems based on super node analysis. So the definition is whenever there is a voltage source connected between two unknown voltage or non-reference nodes, then the two nodes are joined to form a single node which is called as the super node. So looking at the circuit diagram given here, we have V2 and V3 as two non-reference nodes, that is the voltage at these particular points is unknown. And in between we have a voltage source. So whenever we have a voltage source which is connected between two non-reference node or two unknown voltages, then we have to apply super node analysis. That is, we have to consider these nodes together forming a super node. So V2 and V3 will be considered together as a single node which is called as a super node. So the properties of super node are the super node does not have any well-defined voltage. So here we are combining both the nodes V2 and V3 to a single node, which means we cannot predict whether it is having a value of V2 or V3. So that is why it is mentioned that it is not having any well-defined voltage. Next, to solve the problems based on this particular super node analysis, we have to apply both Kirchhoff's current law and Kirchhoff's voltage law so that we can solve for the voltage at the particular super node. Like we have seen now, here we have V2 and V3. When it is converted into a single voltage source, let us assume that it is having a voltage of V. So to calculate the value of V over here, that is at the super node, we have to apply both the KCL and KVL equations here. Next, any circuit elements, for example, if it is resistor, can be placed in parallel within the super node. So the positions can be made in a parallel way. Next, at each super node, the KCL is always satisfied. So this is very important. Then within the super node, the voltage difference between any two nodes is always 0. So if we consider the two different nodes, that is between V2 and V3, the voltage difference, that is V2 minus V3, will be equal to 0. So that is mentioned in the properties of supernodes. Now let us see how to solve problems based on this particular supernode analysis. So let us solve an example which is from GATE 2014 question paper. In the given circuit, the value of node voltage V2 is. So we have to identify the value of V2 over here, which is our question. So looking at the circuit diagram, we have got a super node between V1 and V2. So these V1 and V2 are unknown node voltages, which means here we have got a voltage source which is connected in between. So this particular thing forms a super node. So whenever we have super node, we have to apply KCL between node 1 and 2. So this is our first step. So we have to identify the super node and we have to apply KCL over there. So applying KCL at this junction, the value of current is 4 here. So 4, which is equal to the value of voltage is V1 divided by the value of capacitor, which is minus J3 plus, next here it is V2 divided by J6 plus V2 divided by the other value under R is 6. So solving this, we will get it as 4, which is equal to J2V1 plus V2 minus JV2 divided by 6. Solving this further, we will get 24, which is equal to J2V1 plus 1 minus J into V2 after combining the values of V2. This is our first equation. Now we have to apply KVL, which is our second step, that is at the supernode junction. So this is our supernode. Here we will have the potential difference will be equal to the given source voltage. So here it is V1 minus V2, which is equal to the value of voltage source given is 10, 0 degree. So we will get it as V1, which is equal to V2 plus 10. Let this be our second equation. Now we can substitute second equation in first equation, so that 24, which is equal to J2V1, and instead of V1 we can write it as V2 plus 10 plus 1 minus J into V2, which is equal to J20 plus 1 plus J into V2 after combining. Now V2 is equal to 24 minus J20 divided by 1 plus J, since this is equal to 24. Now we have written the equation for V2. So now we can take the conjugate value. So it will be 24 minus J20 divided by 1 plus J into 1 minus J divided by 1 minus J. Solving this, we can get 24 minus J20 minus J24 minus 20 divided by 2, which is equal to 4 minus J44 divided by 2, which is equal to 2 minus J22 volt. So this is the value of V2. This is the question that we have asked for. So we have calculated the nodal voltage, which is V2. So whenever we have the problems in this way, that is whenever we have super node problems, then the first thing is we have to do KCL between the two nodes, that is wherever we have the super node. So between those two nodes we have to apply KCL first and we will get an equation. Next, at the super node point we have to apply KVL again and we will get one more equation. Using those two equations we have to solve for the given question. Next question, in the circuit below, what will be the voltage at the dependent source, that is under the current source? So we have got dependent source, which is a current based source. So we have to apply the KCL value at the node having the voltage of V. So at this junction we have to apply KCL now. So the value of current is 10, which is equal to the current flowing across this particular branch is equal to Ix. Next, across here it is 2Ix plus here we have the value of V. So the current is unknown here, so we can write it as V by R. So V divided by R value is 1 plus under this particular branch it is V. We have a voltage source also, so V plus 8 divided by the value of R is 2. So we have to solve this now. 10, which is equal to 3Ix plus 3V plus 8 divided by 2. So let this be our first equation, and the second equation is given the value of V, which is equal to 2 into Ix. So this is our second equation. Now let us replace this in our first equation. So we will get it as 10, which is equal to 3Ix plus 3 into value of V, which is 2Ix plus 8 divided by 2, from which after solving we can get the value of Ix as 1 amperes. The question is all about the voltage at the dependent source, which means V is equal to 2Ix. We have to substitute Ix over here. So we will get it as V is equal to 2 into 1, which is equal to 2 volt. So this is how we have to solve for the given question. Next question, find the value of V1 and V2. So here we have a voltage source connected in between V1 and V2, which are nothing but non-reference node, which means this particular junction forms a super node. So as we have seen earlier, whenever we have a super node concept, we have to apply both KCL and KVL. So first we have to apply KCL between V1 and V2. So applying KCL, we will get it as the value of current is -2, since it is flowing in the opposite way, because the current will be considered in this direction and it is in opposite way. So -2 plus the voltage at this particular junction is V1 divided by R value, which is 2, plus under here it is V2 divided by R value is 4, plus we have a current source and it is flowing in the same direction, so it is +7, which is equal to 0. Solving this, we will get 2V1 plus V2, which is equal to -20. Let this be our first equation. The second step is we have to apply KVL at a super node now, which means here we have to apply KVL, which means the potential difference will be equal to the value of the given voltage source here. So we can write it as V1 plus 2, which is equal to V2, or we can write it as V1 minus V2, which is equal to -2. So now we can add the two equations. So first equation is 2V1 plus V2 is equal to -20, and the second equation is V1 minus V2 is equal to -2. So adding this, we will get 3V1 is equal to -22, from which V1 is equal to -22 by 3. So we have calculated the value of V1 now. To calculate V2, we can simply substitute the value of V1 over here. So V2 is equal to V1 plus 2. V1 is -22 by 3 plus 2, which is equal to -16 by 3 volt. So these are the values of V1 and V2, and this is how we have to solve problems based on supernode analysis. Now let us solve one more example where we have got a voltage source which is connected between the two non-reference nodes V1 and V2, and we are supposed to calculate the value of V1 and V2. To solve this particular problem, as we have seen earlier, we have to apply KCL first. That is, we have to convert this particular supernode. That is, we have V1 and V2. Converting this into a supernode, we will have a single node where the other branches are connected in this particular way. So applying KCL at this junction, the current is flowing in this direction and the current given is also in the same direction, which means 2, plus across this branch it is V1 by 1. Across this branch it is V2 by 1, plus across the last branch it is V2. Here we have a voltage source, so it is V2 minus 2, since the direction is opposite, divided by the R value, which is 1. Solving this, we will get V1 plus 2V2 is equal to 0. Let this be our first equation. Now next is we have to apply KVL at the supernode junction. So at this particular junction, the value of V1 minus V2 will be equal to the given value of voltage source, which is 1 volt, or we can write it as V1 minus 1 is equal to V2. So let this be our second equation. Solving 1 and 2, we will get 3V2 is equal to -1 and V2 is equal to -1 by 3. The value of V1 from the second equation is 1 plus V2. Substituting that over here, we will get 1 minus 1 by 3, which is equal to 2 by 3 volt. In case if you have any doubts based on supernode analysis, you can post it out in the comment section. Thank you so much, friends.